Hello and good afternoon, CSI258 Section 847 students for the second 8-week term at Anne Arundel Community College. This is going to be the PacketTracer activity tutorial for PacketTracer 3.5.1.2, which is the Skills Integration Challenge for Chapter 3, and we've got all kinds of activities going on over here. So we're going to go ahead and practice a variety of skills. We're going to take a look at some VLANs, PPP with CHAP authentication, static and default routing using IPv4 and IPv6. And so let's go ahead and jump right in here. And these skills integration challenge activities are always some of the most rewarding because it really allows you to take all of the the tools in your networking toolbox that you've acquired so far and allows you to put these into action. So we've got our VLAN table up here. So it says complete the addressing table by assigning the following addresses to VLAN 25. So router 2 is going to have gig 00.25. It's going to be the first IPv4 address. So if we scroll back up here and take a look at router 2, you can see that we've got 192.168.1.192.1.0, which is a /25, and then followed by a .224, which is going to be a /27. And then we've got another /27 right here, and then we're kind of left and we need to figure out what is the address going to be there. And so as you can see, it's going to be 50 hosts in terms of usable IPs. So we know that it's probably not going to be a /25 because that would be 126. So let's go ahead and let's work this out. So we've got our pin here, and scoot over here, get to find some space. So you can see that the subnet here, right, starts out, we're going to use the addressing scheme is going to use 192.168.1.0/24, and we're going to subnet this down. And additional address space is available between VLAN 15 and VLAN 1. And so here's VLAN 15 and VLAN 1. And you can see the address space that's being used here. So VLAN 25 needs enough addresses for 50 hosts. So we know that from 192.168.1.0 up to, and this is a /25, so it's going to be to 192.168.1. And since we're only borrowing 1 bit from the hosts, that leaves us with 7 host bits. So we have 2 to the 7 is 128. And then we're going to go ahead and subtract 2, so that would allow 126 hosts, which is why you can see here it's indicating that we've got 100 host addresses that we're going to be able to use. So the block size is going to be 128. So this subnet is going to cut off, and we'll say this is subnet number 1. It's going to stop at 127. Now you'll notice that this one does not pick up at 128 for the network ID, and likewise here for the network ID. So we're pretty sure that the space in between is going to start with 192.168.1.128. Now, we need enough host addresses for 50 hosts. So we'll take a look at, let's say, we'll start at the very bottom. So 2 to the 0, that's only going to give us 1 host. 2 to the 1, well, actually I shouldn't even say that. So this is going to give us 0 because we have to subtract 2, right? So this would actually give us -1. This is going to give us 0. So now we really start. So 2 to the 2, right? This would be a /30. And 2 to the 2 is 4 minus 2, right? And the reason I'm subtracting 2 here, again, as a reminder, we need to take off the network ID, right, which is going to be the first address, and the broadcast address, which is going to be the last address in the subnet. So this would give us 2 usable host IPs. If we did a /29, where I've only got 3 host bits, 2 to the 3 is 8, minus 2 is going to be 6, and that's not going to do it either. What about 2 to the 4? Well, that's going to be 16 minus 2. That's going to give us 14, a little closer, but still not there. If we look at 2 to the 5, that's 32 minus 2, so that's going to be 30 usable host IPs. And then finally we've got, I shouldn't say finally, we've got 2 to the 6, which is going to be 64 minus 2, and that's 60 2 usable IPs. So let me fill this guy in. This would be a /28, /27, and a /26. So it looks like the /26, which gives us 62 usable IPs, is going to be the magic key here. And so by default, right, if we were to do the subnet mask out, we're borrowing 2 host bits. So it would look like a 255.255.255, and then we're borrowing the first 2 bits, which are going to have a value of 128 and 64, and that's going to give us 192. So 192. So this is going to be our subnet mask. And the convenient thing is, you'll notice that we start out at 192.168.1.28. Our block size is 64, and that takes us right up to 192.168.1.191. Is that right? Let me make sure I've got that right. 128, and we've got 64. Yeah, because it'll stop off. The next network ID would be at 192. Yep, so we stop off at 191, and that dovetails nicely off of the VLAN 1 subnet right here. So that's how we would figure out our available, the next subnet and the address space that we're going to be using. So let me go ahead, clear the screen, and then I'm going to write that information back into the designated location. So we would be 192.168.1.128. That's our network ID. Subnet mask is 255.255.255. I'll go up here 192, give it some room. And that's going to give us 62 usable host IPs. Right? So the first usable IP is going to be .129, and the last usable IP is going to be .1. Oops, sorry. Let's back that up a little bit there. Back that up. It's going to be .190, because again, 128 is the network identifier, network ID, and .191 is going to be my broadcast address. All right, so now with these addresses in mind, let's answer some of these questions. So R2, so the sub interface here on gig 00 on router 2, first IP, we've got that 192.168.1.129. And then it says PC25 is going to be the second IPv4 address. That's going to be .130. And then L25, which looks like it's a printer, is going to have the last IP, which is going to be .190. All right, so it says configure IPv4 addressing. Configure IPv4 addressing on the necessary end devices. So let's go ahead and make that happen. So we'll start here with L25, and let's see what we've got here for an interface. Definitely a printer. And we're going to be using a static IP. We're looking at the fast Ethernet 0 interface, so we're going to say 192.168.1.190, because L25 is getting that last address. Now it automatically fills in the default Class C subnet mask because we are using a Class C address. However, we've subnetted the address. So 255.255.255.192. All right, so that takes care of our printer. Let's take a look here. Yeah, so that takes care of the printer for now with that address. Let's jump onto PC25. We'll pull down PC25 here, and we're going to do a static IP for the PC, which is going to be 192.168.1.130. Again, we get that default Class C mask because we are using a Class C address. And the default gateway, now we need to take a look here. So PC25, and I'm going to have to scroll up a little bit. PC25 is, there's the IPv6 address information, which we can put in. And I'm going to need to see where PC25 is supposed to be VLAN-wise. Let's see down here, VLAN 25, FA19, so it is VLAN 25. And so VLAN 25, we're going to be using that sub interface. So let me go ahead and get the information in here. So the default gateway would be 192.168. And so a lot of your success here in this exercise is dependent upon correctly calculating the address space that can be used. So we're going to go ahead and say 192.168.1 dot, and it was the first address, 129 is going to be the gateway. Let's take a look here at the static IP, and this actually looks correct here already. FE80::2. Okay, good. So that looks correct. So we'll go ahead and we'll close down PC25. We'll scroll all the way down here. That way this lines up for us. And now let's go ahead and jump on router 2. We're going to do our sub interface configuration here on router 2. It looks like there's going to be quite a bit of work on router 2. All right, so whoops. So let's see if it's Cisco, and the enable password should be class. All right, so we are in privilege exec mode. So I'm going to say show IP interface brief. And we can take a look at the IP addresses as they stand right now. As you can see, we do have some sub interfaces already configured, .1, .15, and .99. And those already appear to be administratively down. So let's do a show run. And let's see if these are properly configured. So it looks like the IPv6 addressing has already been applied, and there is no IPv4 addressing there. So we're probably going to have to address that. So let's see, I want to make sure. So it's going to be OSPF. So yeah, so I'm going to pop back here on router 2. As you can see, we've got quite a bit of information here for router 2 that we're going to use. And I'm going to leave that other information there because we're going to, when I slide back down, we'll be able to use that information. So we'll leave it right there. All right, so on router 2, let's go ahead and complete the configuration work. So we're going to go into global config mode with the configure terminal command. And I'm going to say interface gigabit Ethernet 00.1. And so let's do the IPv4 addressing here. So we'll say IP address, and we'll pull it from the table, 192.168.1.193. And the subnet mask there is a 255.255.255.224, or a /27. So we're borrowing 3 of the host bits in this case. And so yes, order of operations. So as you can see here, we have to go ahead and configure the encapsulation .1q, and this is where I'm going to put the VLAN ID in, is going to be 1. Now I can put in the IP address. And so in another video we talked about the order of operations with a router on a stick where we've got sub interfaces, and this is definitely one of the considerations, is make sure that if you are doing router on a stick that you go ahead and put the end cap on the port before you actually put the IP address on there. All right, now let's go ahead and jump to interface gigabit Ethernet 00.15, where we're going to say encap.1q, and it's going to be 15, and that is matching up with the VLAN, right? Because we're expecting a VLAN tag to be presented to the router on this sub interface, and it should be 15. All right, now we can get our IP address on here, which for gig 0015 is going to be 192.168.1.1. And this is a 255.255.255.128, which is a /25. So we're borrowing a single host bit. And now let's jump into the sub interface 0.025. And this is the one that we have figured the information out for. So we're going to say encap.1q25 to match our VLAN. And I'm going to say IP address. And so we know that we're using the first for gig, and you can see it right here, router 2, gig 025 is the first IP address. So IP address is going to be 192.168.1.129, and we know that we ended up with a /26, which is going to be a .192, because again, we're taking those first 2 host bit values, 128 and 64, and that gives us our 192. All right, now we also need to add in, let's double check, I'm not sure if we had that IPv6 information on here yet. We do not, so let's drop our IPv6 address information in here. So IPv6 address is going to be 2001:db8:, and A:25, and I need to refer back up there, :1/64, and we'll hit enter, and then we're going to get our link local address on here, IPv6 address FE80::2, I believe. Yep, ::2 link local. And I wish that it could be as easy every time with IPv6 with the link locals, so that the global unicast addresses, sometimes it's a chore to have to type in all of those digits, but we've got our link locals are nice and simple. All right, so now let's do a do show run, and let's see what we've got now. So we'll scroll up a little bit here, and you can see now we've got our IPv4 address, we've got our IPv6 information, and let's wrap up here with VLAN 99, which could be the management VLAN, and we're going to say interface gigabit Ethernet 00.99. IP address is going to be 192.168, and 99 is .1.225, and this is a .224 as well. So 255, 255, 255.224, again borrowing 3 of the host bits. The values 128, 64, and 32, which when added together gives us 224. And once again, incap.1q99, and then we can hit the IP address. All right, so we've got our values added in there, and we've got R25 done, we've got PC25 done, L25 is done. We've configured IPv4 addressing on the necessary end devices. On router 2, create and apply IPv4 and IPv6 addressing. We just did that. So now we've got one thing left. Let's go under gigabit Ethernet 00 and say no shut. And we're going to see all of these interfaces come online, right? So now if I say do show IP interface brief, you can see we've got all of our IP address information there, and all of our interfaces that need to be up are currently up. I could even say do show IPv6 interface brief. And once again, we see our sub interface information for IPv6, right, along with our IP addresses for each of the respective networks. So we'll say end, and I'm going to do a quick write memory, right? I'm going to save my config off here. So now let's go ahead and step into the VLAN configuration. So let's jump over to switch 1. And we're going to stretch this out here to give us a little more space with which to work. All right, so as you can see here, whoops. As you can see here, we've got Cisco and then class. Okay, fantastic. All right, so on switch 1, create VLAN 86 and name it black hole. So we're going to go from privilege exec in the global config, where we're going to say VLAN 86, and I'm going to say name, and let's make sure we get this capital B and a capital H, name black hole. Now, if I do a do show VLAN brief, you can see that we have the listing right here, right? But we don't have, it doesn't look like we've got any interfaces in any of these other VLANs, and so we're probably going to be addressing that here shortly. So configure switch 1 ports in static mode with the following requirements. So FA01 is the native trunk for VLAN 99. And let me take a look here at router 2 to make sure that when we looked at that interface, it had the incap.1q, and I don't think we looked at it, so I want to do a show run here, because if that's supposed to be the native VLAN, and we did not. So I'm going to step back here real quick. So for the native VLAN, we need to go ahead and call that out on the sub interface. So interface gigabit Ethernet 00.99 and my incap.1q 99 native. So we'll make sure we get that in there right now. Then we'll save our config, and then we're going to transition back to switch 1 here. All right, so FA01 is going to be the native trunk for VLAN 99. So I'm going to go into interface FA01, and we're going to say switch port mode trunk. And as you can see, the interface went down, but then came back up. And now spanning tree is going to do its thing. So while spanning tree is finishing up there, we're going to go ahead and say interface range FA07 to 18. And these are going to be access ports, and they're all going to be in VLAN 15. So we're going to say switch port mode access. So we're going to statically assign them as access ports. And we're also going to say switch port access VLAN 15. Okay, and now let's jump into interface range FA019 to 24. And we're going to say switch port mode access and switch port access VLAN 25, and this is the VLAN of PC 25. All right, gig 1.1 and 1.2 and FA02 through 06 are unused. They should be properly secured and assigned to the black hole VLAN. And so here's how you do that. So we're going to say interface range GI 1/1.2 and then FA02 through 6. Let's see, FA02 through 6. And typically that does work on an actual Cisco switch. That would work. So we'll deal with, and let's see, I have a typo in here. 1.1, do show IP interface brief. Let's see if I've typoed things. Ah, interesting. So, good time for troubleshooting here. So I go to enter the command in based off of what they're showing here in the exercise, and they say gig 1.1 and 1.2. However, those are not the interfaces that reside on the switch. It's actually gigabit Ethernet 0.1 and 0.2. So let's go ahead and shore up that last command, because this command right here should work. So we're going to say gig 0.1 and 0.2 and then FA02 through 06, and there we go. And that's what we want to have happen. So the first thing we want to do is we want to shut these ports down, because we need to secure these ports so that if somebody were to walk up to the switch and plug something in, that the switch is not going to allow them to have connectivity onto the network. So we've just shut the ports down, and now we're going to say switch port access VLAN, and the black hole VLAN is 86. And so we've shut those ports down, and we're even going to go so far, we'll say switch port mode access. And we've got them shut down. All right, so if I were to say do show run now, and here's 06, right? Switch port access VLAN 86, switch port mode access, and then shut the port down, right? And that was for FA02, 3, 4, 5, and 6. All right. So let's see here. VLAN. So we did configure on router 2. We've configured the inner VLAN routing. We did that when we did all of the sub interfaces. And then here is the little reminder. VLAN 99 is the native VLAN, requiring me to go ahead and apply that native tag at the end of the ncap.1q command on that sub interface. All right, so we're halfway done here, and as you can see, you got it. Chapter 3 dealt with PPP, the point-to-point protocol. We talked a lot about HDLC, and we also talked a lot about PPP, and so it looks like we're probably going to be doing some OSPF and some PPP here. So let me go ahead and type in. I'm going to save my config where we're at. So it says configure router 1 and router 2 to use PPP with CHAP for the shared link. And so the password for CHAP is going to be Cisco. So how would we do that? Let me jump back over here to router 2. Let's get router 1 up as well, because we're going to be bouncing back and forth. And as you probably guessed it, we're also going to need router 3. All right, here we go. And let's get router 3 into the, oh, I'm sorry, I was looking at the ISP here, although we may be doing some configuration work here. So we'll start out with router 1 and router 2. So password Cisco, and go from user exec to privilege exec with the enable command, and my password is going to be class. Okay, so I'm on router 1, so let's see, it wants the default routes. We've got some IPv6 information, IPv4 OSPF. But let's go ahead and take care of the link between these two routers, IP interface brief. So let's take a look at the two links here. And clearly on router 1, the 209.165.200, that's going to be out here on serial 001. We're interested in this link right here, serial 000. So the first thing that we should probably do is go ahead and create our response to what will ultimately be the CHAP challenge. So we're going to say username, and the router coming into router 1 is going to be router 2, and we'll say secret Cisco, right? So we've created the username password combination that router 1 is going to respond with to router 2 when he receives that CHAP challenge. Now let's go ahead and jump into interface serial 000, because again, we need to set it up so that it's using PPP. So if I were to say do show controllers serial 000, what do we see? Well, we see right now we're the DTE in here. And so remember that the data terminal equipment in the DTE end here, we're going to be detecting the clock rate. And we're going to pick that clock rate up from the DCE end, the data communications end of this link. And that's where when we go on to router 2, we're going to expect to see that it's the DCE end and that it's setting the clock rate between these two routers. So if I were to say show interface serial 000, and we'll throw a do in front of that, we'll see that our encapsulation type right now is HDLC, right? And this is the high level data link control, and this is the Cisco default, and it is also Cisco proprietary. And this is critical because HDLC was a standard long before Cisco got into the routing and switching business, and it was a standard that was created by the ISO. And then what happened was Cisco took that standard and made one major change to that, and that was the type field, where it allows you to indicate which upper layer protocol, right? Are you using IPv4, IPv6, IPX, AppleTalk? So, and that was the Cisco change. So sometimes it'll be referred to, they'll put a little lowercase c in front of it. So remember that this is the default encapsulation for Cisco devices. So we're going to change that right now by simply issuing the command incap PPP. Now when I hit enter here, what's going to happen is this interface is going to go down, right? Because another key takeaway is that PPP and HDLC cannot interoperate. So it's all or nothing. Both ends of the link need to be PPP, or both ends of the link need to be HDLC. You cannot have one end of your link be PPP and the other be HDLC, because that's what we have right now. And as you can see, our result here is that the interface is down. So we're also going to go ahead and configure our PPP authentication, and we've got two choices here. It's PAP and CHAP. We've been asked to do CHAP, so we'll say PPP authentication CHAP. And so that completes the router 1 side of things. So let's save our config here. Now let's step over to router 2, and we're going to be dealing with router 2's serial interface. So I'm going to go to global config mode with the configure terminal command, and I'm going to go into interface serial 000. And we're going to change the encapsulation. Again, if I were to say do show interface serial 000, you can see that we are still using HDLC on this end, because again, it is the default. So I say incap PPP. That's going to change the encapsulation. Now you'll notice when I do the do show IP interface brief, we see a very common problem with serial links when you've got things misconfigured and you're using CHAP authentication, is that we are up, down. And what this means is the status is at layer 1, we are up. So there is connectivity from a physical layer perspective between router 2 and router 1, and that connectivity has been sensed and it's up. However, at layer 2, the data link layer, we are down, and that's the layer where the link control protocol, which is part of PPP, is furiously right now trying to negotiate the CHAP authentication, and that's not taking place because we haven't configured the required authentication on router 2. If I come back to router 1 and I were to type in debug PPP, and I hope they've got it, there it is, authentication, and I hit enter, the hope is here is that we would see, and here we go. So IPCP, that is the IP control protocol. And you can see I've got an inbound configuration request, outbound configuration acknowledgments. However, it's not coming up, right? You can see that it's staying closed because what we're after is getting it to an open state. And again, the debugs here, within PacketTracer anyway, are sometimes a bit confusing. And again, I have a previous video where we went ahead and set up something similar to this with the debugs, and you can get a lot better information. So I'm going to go ahead and I'm going to say you all, which just simply means undebug all. All right, back to router 2. So let's get our username set up so that we're going to respond with. So when router 1 challenges me, I'm going to respond back with router 1 secret Cisco. And I'm going to put that into my configuration here on router 2 because that's what router 2 is going to respond with. And as you can see, the state changed to up already, and we haven't even gotten into do show run. Let's make sure I do not remember. NCAP PPP is on there, and again, well, this is actually a good thing here, right? So you'll notice, what command do we not have in here for PPP? So we don't have the PPP authentication CHAP command here because, and this goes back to sort of the dial days where if you were to look at, let's say, router 1 as the service provider, right, they set the PPP authentication CHAP command first, which means they are issuing the challenge to router 2 because they are saying to router 2, hey, you need to identify yourself and respond to me with that password information that we configured on router 2, which is basically R1 with the matching password that we have here on R1. And then R1 is going to acknowledge back. And so that's kind of the sort of the three-way handshake, if you will, that CHAP authentication performs. So in the olden days, right, with the service provider here, the service provider would challenge, let's say this is the CPE, or you'll see it referred to as just the CE, Customer Edge Device. Because if you think about it, it makes sense. The customer really wouldn't challenge the service provider. It would be the service provider who's going to challenge the customer. And so if we come back down here, let me go ahead and clear the screen here, and let's get rid of some of these lines that we've drawn. So if we were to say on router 2 right now, do show IP, oops, let's come back a little bit, do show IP interface brief, you can see that our serial link is now up. And let me ping the other side of this link. Do ping 10.1.1.2, and as you can see, we've got connectivity. But we never configured this side of the link for PPP authentication. And again, the textbook shows you to do it both ways, and there's nothing wrong with doing it like that. It's just simply that that really wasn't sort of the classic use case. But let me give you a case where that would be a good use case, is where you've got two sites that you control, right? And let's say you've got a serial link here, and let's say that this one's in Alaska, and this one is in DC, and you control both router 1 and router 2, chances are you might want to have mutual authentication here, where PPP authentication is configured on router 1 as well as on router 2. That way you've got challenges going this way and challenges going this way on both ends of your links. And again, there's nothing wrong with doing it like that. It's just that that is not, or wasn't back in the day, sort of the classic scenario and use case that you would see. So I'm actually going to clear the whole screen here, and I think we're done with the IP addressing scheme that we had up there. All right, so we've got connectivity set up there, so that's good news. And let me finish out here. Let's see if we would have been penalized for not putting in here PPP authentication CHAP. So we're at 59 points. And yeah, that was worth 2 points right there to configure. Even though the interface came up, right? The SIM is definitely, PacketTracer is looking for you to have that mutual authentication set up. And again, nothing wrong with doing it like that. All right, so now we're into the routing. So on router 1, configure IPv4 and IPv6 default routes using the appropriate exit interface. And you just by taking a look here, you can see we're going to default out to our ISP out serial 001. So let's go from privilege exec into global config with the configure terminal command, or conf t, and I'm just simply going to say IP route. The quad zeros, we'll do our IPv4 first. And what's our exit interface? Serial 001. Right, and that's okay. Default route without gateway. If not a point-to-point interface, well, this is, so we're good. And then we're going to say IPv6 route. // zeros out serial 001. So we've got our IPv4 and our IPv6 default routes set up. So now we're going to configure IPv4 OSPF with the following criteria. Right, so let's go ahead. I've got that a little highlighted there. So process ID 1 on both routers. So let's say router OSPF 1. And they're both going to be in area 0. And let's get our router ID set right away. 1.1.1.1. Advertise specific subnets. So they must be looking for the 10.1.1.0. And this is going to be, again, it's a wildcard mask here. So 0.0.0.3, because that is the net mask is a 255, 255, 255, 252. So if we take the inverse and subtract it, we end up with 3. And so that's going to be the subnet mask there, or I'm sorry, the wildcard mask there, and that's area 0. And that is really the only subnet that we need to advertise. And I'm looking to see on router 1, we're going to do default information originate, because we're going to be sending the default route into the OSPF domain. And it looks like that is it on router 1. So let's say do show run and take a look at our OSPF config. So there we go. Router OSPF 1, we have log adjacency changes is automatically turned on for us. We've got our transit network being advertised here, the 10.1.1.0. And that should be at default information originate. We should be good there. So now let's step over to router 2. And router 2, we've got a little bit more work to do here because we've got all of those sub interfaces that we're going to need to address. So let's exit out of the interface configuration mode, and we'll say router OSPF 1. We're going to set the router ID right away to 2.2.2.2. And now what we're going to do is we're going to enable OSPF to run on certain interfaces. Specifically, we want to make sure that we have, and does it talk about passive interface anywhere? Okay, I don't see anything about passive interfaces. So if I say do show IP interface brief, you can see we've definitely got some subnets here that we're going to want to advertise out. So I'm going to say network, and we'll do the first one, 192.168.1. And in fact, we could probably roll back up here, and this is going to help us out. So it's going to be 1.192, and the subnet mask is basically a /27, so it's a 224. So if we subtracted 224 from 255, we get 31. So 0.0.0.31, and that's going to be in area 0. And now we're going to go ahead with our next network statement. It's going to be 192.168.1.0. And the subnet there is, let's go back up there, is a /25. So with a .128 as our network mask, we take the 128, subtract it from 255, we end up with 127. And that's also in area 0. And let's step back here now. The next network is going to be the network which we had to figure out, which is 192.168.1. And let me take a look back down here as I'm now trying to blank. look up here. So 129, so 128. And this was a /26, so it was a 192. So take 255 and subtract 192, and you should end up with 63. And that's also in area 0. And then we've got one last one here. Actually, we've got 2 more to go. So we're going to say on the final, the subnet, or I'm sorry, subnet, for our VLAN 99, it was 224 was the network ID, and it is a /27 as well, which is going to be a 224, and so that would end up being 31, because 224 plus 31 gives us 255. And so we're going to hit enter there, and then finally we're going to go ahead and add in the transit network here. And the transit network's the network between router 1 and router 2. And you'll notice we haven't seen anything come up saying that we have a full adjacency. So if I say do show IP OSPF neighbor, we have nothing, right? Because I haven't started the OSPF process on serial 000 here on router 2. And so by starting the OSPF process, the hello packets are going to go back and forth and be exchanged between router 1 and router 2, and then that adjacency is going to come up. So it's going to be 10.1.1.0, and this is a /30, so it's going to be 0.0.0.3, and it's going to be in area 0. When I hit enter here, we should see some activity with respect to our adjacency, and there we go. So if I were to say do show IP OSPF neighbor now, you can see we have a neighbor, and it's router 1. All right, so we've got our IP address information in there for router 2. So where are we at here? Advertise specific subnets, we did. So let's go back over here to router 1. So on router 1, when I say do show IP OSPF, you can see OSPF is running. I want to see my neighbor, right? We've got router 2. And again, the priority, the default priority for serial links is 0 because there is no DR, BDR election on serial links because it's a point-to-point interface. So if I were to say show IP route or do show IP route, you can see that we are learning the 192.168.1 subnets that we're advertising from router 2, right? So let's see, can I ping, if I were to say do ping 192.168.1 and I'm trying to remember the PC25 IP was the second IPv130. IPv4 address, do I have reachability? And I do. So from router 1, I can actually ping over to PC25, right? And that's good news. So we've got that knocked out. We're 3/4 of the way done here. So now let's take a look at our IPv6 configuration for OSPF. So we're going to use the same process ID. So let's go ahead, we'll take care of router 1 first here. So I'm simply going to say, let's exit out of the router config mode. So it's going to be IPv6 router and then OSPF and my process ID. So IPv6 router OSPF 1. And again, IPv6 routing not enabled. So what do we need to do here? We need to turn it on. So it's IPv6 unicast routing. So we have to remember that for router 2, where I'm assuming it's also probably not on. So let's pull that IPv6 router OSPF command back, and we're going to say router ID for router 1 is again 1.1.1.1. And remember, we're using 1.1.1.1 twice, because in this case, remember that with OSPF, it's not an IP address. It's in an IP address format, but it's just a router ID. It's all it's being used for here is to identify this router from the other routers in the OSPF domain. If you were to ping 1.1.1.1 right now, that address is not configured. It would not return successfully. So that's why we're able to use this twice. Okay, so we did the process ID of 1. Routers R1 and R2 are in area 0 on appropriate interfaces on R1 and R2. So for router 1, it's very straightforward, right? We only have one interface, serial 000, because we would not be running OSPF between our serial 001 interface and the ISP, right? So I'm going to say interface serial 000, and it's IPv6 OSPF, and the process ID is 1, and then the area is 0. And so now if I say do show IPv6 OSPF neighbor, we don't see anything yet. If I pull the neighbor command off, you can see that the process is running, right? Excuse me. So let's go ahead now and jump on to router R2, where we've got some substantial work here on the router 2 side. So the first thing we want to do is, IPv6 unicast routing. So we'll turn our IPv6 routing on, and then we're going to go ahead and say IPv6 router OSPF, and the process ID is 1. We're going to set our router ID to 2.2.2.2. And now another reminder here, right? With IPv6 or OSPF v3, which is using IPv6, you'll notice, what am I not doing? I'm not entering network statements in. And if I do a question mark here, I've commented on this previously in some other videos, there is no network statement with OSPF v3 with IPv6. The only way to get it turned on is to actually go to the interface and enter in the command to turn it on. So we've got it set up here. We've got our process ID set. We have IPv6 routing on. And we've got our router ID configured. So now let's get onto some interfaces here. We'll start with serial 000. And it's very straightforward. IPv6, OSPF 1, area 0. We should have an adjacency that forms between router 2 and router 1. And we'll move on, and there it is. And we'll move on to the other interfaces now. And this is sort of the long pole in the tent, if you will. So we're going to go ahead and say interface GI00.1. And it's that very same command, IPv6 OSPF 1 area 0. We're going to go into interface gigabit Ethernet 00. And let me pull these back here, make sure we get them all. .15. IPv6 OSPF 1 area 0. We're going to go into interface gigabit Ethernet 00.25. IPv6 OSPF 1 area 0. And interface gigabit Ethernet 00.99. IPv6 OSPF 1 area 0. All right. So we've got OSPF running, we did, and let's see here. There's no call for any passive interfaces, so let me go ahead and end and type write mem. We'll take a look over here, and let's check on, we've got our VLAN 99. So no ports went into VLAN 99, that's our management VLAN. All devices should be able to ping the web server. So let's give that a try. Let's pull PC25 up here. And we are 10 points short. We're going to go take a look at that here in a second. But let's see if we've got end-to-end connectivity. So can I ping 209.165.201.2? And so we're going from PC25, which is VLAN 25. First request timed out, and then we've got success. Let's go ahead and try to ping 2001:DB8:B:2:2. All right, destination. Oh, I'm sorry. I hit a 1 there instead of the 2. So let me get this back here. Let's try that again. Or I'm sorry, it is. So 2001:DB8:B:2:2. And that is coming back destination host unreachable. So we may have some IPv6 work to take a look at. Let's look at PC15. And we're going to go ahead and type in ping we'll get this right here, 209.165.201.2. All right, we've got IPv4 connectivity, and let's see if we get the same feedback here. If I ping 2001:DB8:B:2:2, and we get destination host unreachable. All right, so let's go ahead. We've probably got something here. Let's take a look at the IPv6. Configure IPv6 OSPF using the following requirements. Process ID 1, we did that. We're in area 0. We've got the appropriate interfaces configured. Router 1 is correct. Router 2 is correct. So let's see if there was something they were looking for that I have overlooked here. Aha! So it looks like on the usernames, incorrect for the CHAP. So we'll go back and take a look at that. Oh, haha, no wonder we couldn't get out. So we configured the default route, however, and the username. So we'll take a look at the usernames here. I may have put the wrong usernames in. All right, so we configured the default route. We ran the default information originate. Let's make that a little smaller. Ran the default information originate on router 1, and we did it for IPv4, but we never did it for IPv6. So let's jump back in here and say IPv6 router OSPF 1, and let's do a default information originate. In fact, before I do that, if I come over to router 2 and say show IPv6 route, you can see we don't have a default route out. And so that's why we're receiving those error messages. So from the router, I try to ping 2001:DB8:B:2:: whoops. And we're going to have to wait a second here. There we go. Pull that back, :2. Let's see what happens from the router's perspective. You can see the router can't get there because it doesn't have any routing information to get there. So here's what I'm going to do. Is the repeat command available here? So if I said 100, I can't repeat. So we're going to do this pretty quick. I'm going to say ping, and I'll see if I can get back over here to router 1 and type default information originate. And then if we step back to router 2, but when OSPF gets it pushed out, there we go. Right at the very end there, we got that final ping. So that's what it was. We needed that default information originate from our IPv6 OSPF process. So now if I come back to PC 25, take a look at that. We've got full connectivity, so good news there. Take a look at PC 15, and we've got full connectivity there with IPv6 now. So let's come back down here, and I think I assumed to use PPP CHAP with a shared link. The password for CHAP is Cisco. And did I put things backwards? So default gateway for L25, let's take a look at that. So we'll pull the printer up here. And static gateway. I'm wondering if that's where it wants it or if it wants it here. Okay. So it looks like it wants the gateway here for 192.168.1.129 is going to be our gateway. And I'm going to go ahead and close that down. There's no DNS server. And so, yep, so it bumped us up there. So let's take a look one more time here. So the usernames are incorrect. So there's something up with the CHAP configuration, and that static route, and it couldn't have been typoed because it's working. Native VLAN on fast Ethernet 0. Ah, okay. So I see there. So let's take a look at the two quick ones, which are going to be the static route and the switch setting. It was looking for the trunk link that we set up. So we'll say Cisco and then go to privilege exec with class, and we'll go to global config. And interface fast Ethernet 0/1, so it's going to be switch port trunk native VLAN 99. So I left that off of, say do show run, we left that off of FA01 where we set it up to do the trunk mode, right? But we didn't put in the VLAN 99. So now we have that. So now the next one is going to be and now I'm trying to blank here real quick. Hold on one second. Now that we took care of that, let's go ahead, and it was going to be, yeah, the static route for V6. So let's take a look at the static route that we put in for IPv6. So do show run, and there it is, and it's serial 001. IPv6 route : /0. So the route is there. Let me see if it gives us any additional details here where it's looking for it. And this is under router 2. IPv6 unicast routing static routes. Route 0 on router 2. Alright, let's take a look here. So I actually see show IPv6 route. So I actually see it just like I should as a redistributed type 2 external route. So why does it not like that? Alright, so I'm going to do this here. So let's say write mem. When all else fails with PacketTracer, sometimes it's okay to give it a little bump. So we're going to let it reload here, come back up, and we'll say Cisco, and we'll go to privilege exec, show IPv6 route, and we're going to wait for the OSPF to converge. There it is. And so I should be picking, there it is. So I've got the default route there. I wonder why it doesn't like that. So let's check on router 1 here, and we're going to say write mem and give it a little kick. And then we're going to come back and take a look at the usernames for CHAP because it didn't like the usernames that we had configured. Alright, so come back up here, Cisco, and we'll go to privilege exec with class. So show IP route. So the static is defined there, and did it ask for, let's see, on R2 configure an IPv, okay. So it wants us to configure the static on R2 using the interface even though we're picking it up. So maybe it does not want, so I think I see what went wrong here. So on R2 we're going to go into global config mode and say IPv6 route : /0 serial 000, and that's what it's looking for there. So it was interesting. I made the assumption as we were going through here that since we had to propagate the default route out to for IPv4 information from router 1 to router 2, I made the assumption we would do the same thing. However, right here it's asking for us to specifically put that information on router 2. So what we can do on router 1 then is come back and say IPv6 router OSPF 1 and say no default information originate. And we're not going to lose any points there. So let's go ahead and take a look now. So we've got host name is R1, so it doesn't like the usernames that we're using. So I'm using username R2. And let's check here. Let me take a closer look to make sure that they didn't specifically ask. Configure R1 and R2 to use PPP with CHAP for the shared link. The password for CHAP is Cisco. And so it should be that R2, when it challenges, needs to be set on, and maybe they don't like the secret. Let me do this. So let's do this. Maybe it's that the secret they don't like. So I'm going to say no username R2 with the secret. So we'll say copy and paste, and we should find out pretty quickly. Username R2, and I'll just say password. Maybe they're looking for that. So because it doesn't say to use the secret, and sure enough, that was it. So it did not like the fact that I used the secret. Even though the adjacency came up, it wasn't looking for me to add sort of that little extra something to the username setup. So we would just simply say no username R1 secret, and I'm going to say copy and paste. Okay, and then we know what to do here, username R1. So it's not that the usernames were wrong, it's that it didn't like the fact that I had used the secret. So we'll say password Cisco, And that is going to wrap it up. All right. So again, fantastic activity. And let's take a look one more time. Do we still have our IPv6 connectivity? We do. Let me check the IPv4 connectivity. Make sure it's still functional. And we're probably going to have to ARP out for our default gateway, and we just did. So there we go. All right, so this has been a fantastic activity. Allows us to pull together some of our old VLAN skills, definitely router on a stick skills, and we got to incorporate a lot of the PPP with the CHAP authentication, switching the encapsulations between router 2 and router 1, and then another pretty good look at OSPF v2 for IPv4 and OSPF v3 for IPv6. Okay, I hope that this has cleared up any confusion that you might have had, and I will see you all on Saturday. Thank you for watching.